Hello students. So here's the video guide to solve the selected questions from your textbook. This one is on exercise 10B. There will be a trigonometric ratio. So here we go. So this is the first question that you are told to try. You are given this triangle over here, and we are supposed to find the length of AH followed by HC. So as you can see, there are actually some right angle triangles here we can use. Triangle ABH is one, and of course the triangle ABC, right? So we have that. So how to find AH? Right, to find AH, you can see that AH with respect to the angle 56, it is actually the opposite leg, and then 8.5 meters, 8.9 meters, that's the hypotenuse. So opposite over hypotenuse, that will be the sine ratio, therefore is equals to sine 56. So AH is equals to 8.9 sine 56. You just punch these numbers into the calculator, you should get 7.38 meters rounded off to three significant figures, right? Next, we are supposed to find the length of HC. So how do we go about doing it? Well, one of the ways we can do it is actually, okay, if you look at this is a right angle triangle ABC. So using the angle sum of triangle, we can figure out that angle ACB on the other side, this is actually 34 degrees, right? So once we have this angle, we can use triangle AHC, right? Tangent 34 here, this 34 is opposite, which is AH over AC. And we already know the value for AH, right? AH is 8.9 sine 56 degrees. We already have that. So AH over tangent 34 will give us a HC. That will be 10.9 meters, three significant figures. Okay. Next question. Next question. This is a question that we want to look at. There are a few lengths we want to look at. We want to find TQ over here, which is over here. PT is over here. And PR is the long length over here. So how do we go about doing that? Let's take a look. Okay. So first, to find TQ, okay, we just need to look at this little triangle over here, right? TQS. It's a right angle triangle. So sine 60 is going to be the opposite, which is TQ, over hypotenuse. The hypotenuse is 25 centimeter over here. So TQ is going to be 25 times sine 60. That will give us 21.7 centimeter, three significant figures, right? Now, next one, we are supposed to find PT. Okay, so how can we do that? Well, to find PT, we can first find this angle, right? This angle over here, SPQ, okay, or TPQ. Okay, there are a few different ways to label it, but basically it's this angle at the point P. So this angle, using angle sum of triangles, because we have this, right? 90 degrees, 60, so down here with 30. So tangent 30 will give us the opposite, which is TQ, over the adjacent, which is PT, right? TQ, we already have the value of TQ from the first part of the question. That will be 25 sine 60. So 25 sine 60 over tangent 30 degrees, that will give us 37.5 centimeter. So that will be PT. So after we get that, finally we are supposed to find PR. So to find PR, we need to find PQ first, right? And we also need to find QR. So then we can add them up together. Now QR is straightforward. QR is the same as QSY because it's an isosceles triangle. Okay. If you want to be sure, okay, actually you can also use tangent. Tangent 45 degrees. Tangent 45 degrees is actually equals to 1. So you can actually from there work it out. You can actually find QR itself. But of course, if you can recognize that it's isosceles triangle, your process will be much faster. And to find PQ, well, we already know PT, we already know TQ, we can apply Pythagoras theorem. So PQ is 43.301, add them to 25, 68.3 centimeter, three significant figures. Good. Okay, the next question, this time round they give us a quadrilateral like this, and we're supposed to find the perimeter as well as the area. So this particular question, the number of steps is a bit longer. Okay, but nothing too crazy, right? So let's take a look. So first thing we want to do, okay, let's start from the left. We have 154 over here. Okay, that is the hypotenuse. We got the angle 63. We can find Vx, right? So using cosine 63, we can find Vx. Right, cosine 63 is Vx. Sorry, Wx. We are supposed to find Wx first. So cosine 63, we can actually find Wx. which is 69.915. You can also find Vx first, right? If you use sine, right? If you go sine 63, you will actually find Vx instead of Wx. But after you find either Vx or Wx, we can always apply Pythagoras theorem to find the other one, which is what I did over here. So after I find Wx, using Pythagoras theorem, I found Vx. Okay. Then what happened is once we know Vx, okay, we know that the Vy is 88, right? So we can actually once again, okay, make use of Pythagoras theorem, we can find xy. So xy using Pythagoras theorem with Vx at 88, we get 105.28. And then finally we need to find yz, right? To find yz, again we can use the Vy. Tangent 46 is Vy, the opposite over adjacent, yz. Okay, you work it out. Okay, yz is 84.981. Okay, and finally, okay, the last unknown length is actually Vz. So I already know Vy, I know what is yz. Using Pythagoras theorem, we can find Vz. So that's Vz. So once I get all this length, I can answer the question, right? So perimeter is, okay, 154. Okay, follow my cursor, 154. Okay, and then plus Wx plus xy plus yz plus Vz, right? So just substitute the values that we have found earlier. Now the final answer, of course, we want it rounded off to 3 significant figures, which is why if you look at my values earlier, when I'm looking at the length of Wx, xy and so on, I have them more than 3 significant figures. Recommendation is 5 significant figures or more, right, to ensure that when we round off to 3 significant figures later, our answer is accurate. So we do that, I actually got a 537, right? And then finally, to find the area, well, since they are right angle triangles, they are quite easy to find. It's just half times base times height, half times base times height, half times base times height. So plug in the respective numbers, this is what you get. Again, because this is not an exact value, we can actually round off our final answer to 3 significant figures, which is 13200 over here. Okay. Right, so that's exercise 10B. Have a nice day.